this tutorial, I want to draw designer attention towards one of the problem which I face in CSI Bridge. So in one of the project, I draw in initially I use a spine frame model for the analysis purpose. In the detailed design, when I converted this spine frame model into area model, it gave me more bending moment as, as compared to the spine frame model. For that, I created one small simply supported model to verify the result whether the CSI spine frame model and the area model give me equal results or not. So in this regard, what I did, I use one box cutter which has an area of 15.55. So just to verify the result, line model and the spine model and the area model, I calculated first manual calculation. Using the manual calculation, I make this as a simply supported bridge. On the basis of that, I keep it the span length of 30 meter, the box area 15.55, and the density of that bridge is 25. On the basis of this data, I calculate the UDL on the box cutter, which is I am trying to calculate the self weight of the box cutter, which is equal to 6389 kilonewton per meter. Then on the basis of that UDL, I calculated the bending moment and the shear. So the bending moment is WL square by 8, which is a simply supported. I got 43,734, and the shear is 5831. So this is a manual calculation, and I am expecting the almost the same result in CSI line or spine model or CSI area model. For that, let's go to CSI bridge in line or spine model. So if you see, I have already made this model for 30 meter. Let me show you the section property first of the box cutter. Let me modify. So this is a section I have. If I show you my section property is 15.55, which is same what I use in my manual calculation. So once I already analyzed this model to save time. Once I analyze this model and then to see my results. Let me display my result. So the bending moment, maximum bending moment I am getting here 43760. If I go to the shear, so the maximum shear I am getting 5834. So let me put this value in my Excel sheet for comparison. So I have already put this value. If you see this 43760, 5834 for spine or line model results. One more thing I can show you here, the extrude view of this section. So in the line model, once you go to the extrude section, you will find this type of section, which is similar to what I have defined. Now let's go to the area model. If I see my area model here, which is again, if I have a line model, I can convert my line model into the area model by using CSI conversion factor. So if I go to the bridge here, if you see bridge, I need to unlock this model. If I go to update, then if you can see here, I can convert right now. I have this spine model using frame. Now I can convert into area model. Prefer so I can keep it same. If I click OK, so this after some time, this model can same model converted into the area model. Once I converted this model into area model, let's analyze again and see the results. So I have already analyzed this model. Let me show you first the section property, which is should be same. If you can see this area is same. Let's go back and see the results. If once I open the results for the bending moment, I can say for 30-meter span. If you can see, we can see the span from here. So I am getting 50586 bending moment, and the shear force is 67525. Let me put this in my Excel sheet again. So the bending is 50586 and the shear is 6725. Now this is the problem here. You can see that the line spine model or area model have a huge difference here. While if you compare the line or spine model with the manual calculation, we are almost having the same values. There is not much difference. So there is some problem in the area model. So if you are using area model and without realizing that this result may increase, then your box section stress may exceed in the area model, and you can face other problem also, which I will define later. Okay, now if you see this values are change here. So this is one sort of a bug error in the CSI area model. But how to rectify this bug? Let me show you. Let me find out the percentage of that one. That how much percentage increase or reduction in the increase in the area model. So if I divide this area model with the line model, I can get this value, which is around 15%. If you can see, the shear also around 15% more as compared to the actual values, the line model or the manual calculation. So in this way, we can conclude that once we use area model, then we need to apply some reduction factor in the area model to get the same results. So reduction factor I calculated on the basis of the spine model divided by the area model results for the bending and shear both. So you can see that 0.86 if I applied in the reduction factor in area model, then I can get the equal result. Now the question is why we are getting more results here. Let's go back to area model and I will show you why we are getting this result. So if we go to extrude here and apply, so you can see there is a overlapping areas which is contributing more in the self weight of this box cutter. If you see this one, this top slab is because this is a center line modeling. If you see, this is a center line of the web. This is the extra portion is coming and overlapping with this web thickness. Similarly here, similarly here. So this overlapping, this much of area which is overlap here is contributing more load, more self weight and the more bending in the area model, which we need to be reduced to get the actual results. Now some designer may say that okay, we are getting the more results, which is fine. We will conservatively we are designing for more load. But sometime once you have a curve bridge or skew bridge, so you are getting more bearing, more reactions for the self-weight condition, self-weight load case. So once you are getting more bearing reactions, and there is a uplift due to curve in the bridge or a skew in the bridge, and you are depending on the self weight of the bridge, then it means that you are taking risk. So my suggestion to get the actual bending, actual results, and for the bearing reactions. To achieve that, we can introduce reduction factor in my load case, which is somewhere in the analysis. So I have to unlock my model. I have to go here. In this dead load case, I can apply my reduction factor, which is 0.86. Then I can modify this part. Okay, and I can run it again. So the run will take a couple of minutes. So I got this one. Let's go and find out the bending again. If you see now I got the bending of 43504 and shear is 5783. Let me compare this result again. So if you see 58, it should be 5834, but now I am getting very less value. Again, if we go to bending, so bending 43504, which is almost equal to this value. So means that we need to apply some reduction factor to get the same value, equivalent value to this one. So I hope I have defined the problem in the CSI bridge when you are using the spine model and the area model. If you learned something from this tutorial,